Welcome to the third exercise about the advanced sheet metal module. How can we create a model from a flat pattern view? The sketched band command helps you through. It enables you to create bands in an object along a user-defined profile. The banding line must be an open profile composed of a single straight line. Now let's open file 3_sketchedbands.e3. In this example, we shall explain the sketched band command. This model has been obtained starting from a sheet, adding bands along some profiles. In the history tree, let us position on the very first sketched band icon from the bottom. Let's right-click, and then we shall choose Rollback so as to get the sheet and the initial profiles. When the message is issued, let's answer yes and let's go on. Now let's see at least once how the sketched band command works. First, let us select the long central profile and then the face. We shall see the two red arrows show up and the angle box all in the same angle. The arrow identifying the bend direction, which will divide the same face in two, and the arrow allowing you to indicate which part of the face must be kept fixed. Therefore, the first arrow shows whether the bend must be downward or upward bound with respect to the selected face, but also on which side with respect to the profile. So if you double-click on the first arrow, you get it downward, and then you can establish the angle through the handle. And the other arrow shows in which direction the bend will be created. Now let us load the model back again and show how the final object has been obtained. Going forward one step at a time in the history tree, using the rollback here command first, and then the rollback tool in the toolbar, one step at a time. You can see the bends applied one per step. Therefore, you can see how this whole object was created through the sketched band command. And now we shall close without saving. Let's see another example, and let's load file 4_hood.e3. It's a kitchen hood. Now let's open the history tree and let's roll back, still using rollback here, to the original base profile in order to see how the hood has been created. So, linear sweep, a number of drafts, a linear protrusion, and then, so you see linear protrusion, then a number of fillets, till the internal part is emptied using the shell command. Here it is. Then it was further dug with a slot. Take a look. Here is the slot. And then the sheet metal features begin through the face rip command, used to remove material from the fillets. In addition, a linear slot has been performed in order to get another gap. And going on, the hood is unbent and finally rebent again, as you will see. here is the rip. Then the rip is mirrored, and here it is on the other side. Then the hood is unbent, and then, as you can see, it was unbent and then rebent again using the rebent command, and here we have it. So you can take a look at the final object, and on this object we shall see how we can use the sheet metal smart objects. Particularly, we shall apply a smart object here. So let us open the smart object library, view smart objects, and for greater convenience, let's at least temporarily close the predefined view window. After narrowing the smart object library panel, which showed up on the right, so as to make the graphics area larger and better appreciate the model, in the drop-down list on the panel, let us select the library of the sheet metal objects, named SheetMet. And in such library, let us search for object punch lance half bridge by scrolling down the bar, and once we've found it, let's right-click on it and choose Insert in the context menu. Let's position the object onto this face. Once we have positioned the object, we have to rotate it about Z. So first of all, in the orientation drop-down list, let's check that default is selected. In the direction box below, let us select Align Z. Then let us select the handle, and the About Z box shows up. Let's input 2070. Then let us click on first dist, and let us define it starting from this edge, long transversal edge at the bottom, and then the second dist, and we shall define the latter starting from this very edge, short vertical edge of the hood base. In the Show Parameters drop-down list, let us select 2D Profile. Let's set first a distance of 10 mm and the second distance of 50 mm. Let's go on viewing the last flange, choosing the flange item at the very bottom of the list of the Show Parameters box. The inner radius will be 1 mm, and the second length will be 25 mm. And now let us confirm, clicking the OK button on top of the selection list. So we have automatically applied our detail using a predefined smart object. Now, if we enlarge the view a bit, we can see we have the gaps here. One is here, and the other is there. Since we do not want them, let's modify the global object properties. Right-click on the icon of the solid in the history tree, and then let's choose Edit Properties, and then select the Bend Reliefs tab. Uncheck the Enable box and apply by clicking OK on the dialog box. Now let's reopen the Named Views dialog box, and let's take a look at the inclined part and insert on there Object Punch Lance pop-up, specifying the first distance with respect to the right hand edge and the second distance on the one on top. Then in the Show Parameters, let's choose 2D Profile, and then indicate 50 as the first distance value and 100 as the second distance value. Then let us set the show parameters drop-down list to flange. And let's indicate 1 as the radius value and 28 as the length value. Let's confirm by clicking OK on top of the selection list. We have then seen how to make the hood so obtained bendable with these feature types using smart objects. Now let's unbend our hood using the unbend command. And let's see that also the bends belonging to smart objects are unbent, as you can see. Now let's close it again using rebend. And finally, let us close our model without saving it.